NASA's Glory mission offers the potential to dazzle us with discoveries of our home planet's climate. With specialized sensors and orbiting on a path that covers all of the Earth, the Glory satellite is to tell researchers how much of the Sun's energy the planet absorbs or uses and how much gets reflected back out into space. About the size of a refrigerator, the Glory spacecraft will look for those answers in the form of aerosols in the Earth's atmosphere. Particles of solids and liquids that float high in the air, some reaching the stratosphere, are what Glory will detect and map. The sensors are also expected to reveal how long the particles stay in the atmosphere.
Glory will fly two instruments that will help us understand, first of all, the aerosols interaction between the Earth's atmosphere, and then the second instrument called TIM, Total Irradiance Monitor, will help us understand the Sun's interaction with our upper atmosphere.
The answers are expected to be a key piece of the puzzle to figuring out the world's prospects for climate change in the future.
What they're trying to do is define the size of it, where it resides, what are its peculiarities. Is it something that man is doing? Is it something that the Earth does naturally? Is it something that the Sun interacts and causes? Those kind of things.
Glory also marks the return to flight for the Taurus XL rocket, a relatively small booster NASA would like to use to launch future satellites too. Based on existing launchers, Orbital Sciences designed the Taurus XL to meet the needs of small satellites heading into Earth orbit. It has 4 stages and burns a solid fuel similar to the propellants used by the Space Shuttle's solid rocket boosters. The Stage 0 of the Taurus XL traces its heritage back to the Peacekeeper missile. The other 3 stages are taken from the design of the Pegasus booster, but without the signature wing.
The vehicle is very similar to the Pegasus XL vehicle minus the Stage 0, and the first stage doesn't have a wing.
A Taurus XL was launched in February 2009 to lift the orbiting Carbon Observatory, but the payload fairing protecting the spacecraft during the first part of the launch did not separate as it was supposed to. The spacecraft did not reach orbit.
Glory's going to do some fantastic stuff as far as mapping out aerosols in the atmosphere. It's also a groundbreaker in that this is the first flight after a failure of the Taurus XL vehicle, and so we're excited to be doing this. Glory just happens to be the science that we're taking up with us this time.
When the orbiting Carbon Observatory mission did not achieve orbit, the launch team set out to determine what happened, a task made more difficult by the fact that they did not have the failed pieces to examine. Instead, they had to use the extensive data or telemetry they received during the climb into space with extensive fault trees to best figure out the likely cause. The redesign work from finding a probable cause to fixing it has been intense. NASA's Launch Services Program, based at Kennedy Space Center in Florida, operates launches from several parts of the world, so spacecraft can go into different kinds of orbits. This time, Glory required what's called a polar or sun-synchronous orbit to fulfill its studies of Earth's atmosphere. Reaching that orbit means using the Vandenberg Air Force Base, California launch site on the West Coast.
Glory was designed to join what's called the A train or afternoon train of Earth observing satellites. It is necessary to launch from Vandenberg to be able to go into the sun-synchronous orbit. That orbit cannot be achieved efficiently by launching out of the East Coast, for example.
The Glory spacecraft is to become the 5th satellite of the 8 planned to make up the A-Train constellation. Taking readings at the same time on different aspects of the atmosphere, Glory's observations are expected to add more information to the growing database of knowledge about our own planet and how it's affected by the sun and other influences.
It's taken a little longer than we had anticipated, but we're almost there. We're ready to go.